Hey students, it's Mr. Spilker here. Welcome to Chapter 12, Section 4. This will be the final teaching video of Chapter 12, and it will also be the final teaching video here before we take the mid-semester test. So Chapter 12, Section 4, here in Algebra 1. The heading should be the distance and midpoint formulas. Alright, the first focus of 12.4 is going to be the distance formula. So what we want to do is we want to find the distance between 2 points. Now, finding the length of vertical or horizontal line segments on a coordinate plane would be really simple. All you'd have to do is just count the number of blocks from one endpoint to the other. So if you look at the example on the left here, if I were to ask you to find the distance of that line, you would simply count blocks. And if you look at it closely, the line segment is 8 units long. Let's look at the one on the right, the vertical line. What's the distance of that line? Well, once again, since it's a vertical line, you can just simply count blocks. And if you count blocks accurately, it goes up 7 units. Now we're going to ask you to find the distance of several different lines. Not just vertical and horizontal, but also lines that are diagonals. So what do you do if the segment isn't horizontal or vertical? You cannot count blocks. So what would you do? Think about that for a second. Well, hopefully you came up with the idea that you could use the Pythagorean Theorem. Let's use our illustration here to model this situation. We can form a right triangle with a segment. If we drop a segment down and we drop a segment over, we can form a right triangle. We then can count the blocks. Vertically is 3, and horizontally is 1, 2, 3, 4, 5. So if we know that one leg is 3 and one leg is 5, couldn't we find the hypotenuse? And the length of the hypotenuse would also be the distance from one point to the next on a line. So as you can see, the number 5 that I found for one leg came from the difference in x values, and the 3, the vertical line, came from the difference in y values. So now we could use the Pythagorean Theorem to find the length of segment CD, which in this case is just what they're naming the hypotenuse. So if one leg is 3 and one leg is 5, we could plug those two numbers into the Pythagorean Theorem and solve. And when we solve, we would come up with 5.83 units. So the length of that diagonal line is 5.83 units. So students, what I'm trying to stress here is that if you are given a graph and asked to find the distance between 2 points, the easiest way to do that is just use your knowledge of the Pythagorean Theorem. Drop down a vertical line, draw over a horizontal line, count your blocks for your vertical line, your horizontal line, use those two as your legs, and then use the Pythagorean Theorem to solve for the hypotenuse, which will also be the distance of your line. Now, the next question we need to look at is, wonder if instead of giving you a graph, they just simply give you two ordered pairs. Well, if we take the Pythagorean Theorem and derive it, we come up with what we call the distance formula. This distance formula right here is very important to our lesson today. The distance formula basically just says if you want to find the distance between 2 points, you go ahead and you take the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance formula is really quite simple. It's the square root of the difference in your x values squared plus the difference in your y values squared. That's the distance formula. Now once again, students, if I'm given a graph, I would simply drop a vertical line, draw over a horizontal line, and use the Pythagorean Theorem. But if they don't give you a graph, if they simply state two ordered pairs, then I would take those two ordered pairs and plug them into the distance formula. So the distance formula, which is circled in green here, is something that you're going to want to have in your notes. So if they give you a graph, use the Pythagorean Theorem. If they give you two ordered pairs, use the distance formula. Both the Pythagorean Theorem and the distance formula would produce the same measurement if you were to apply both to the same problem. Let's go ahead now and look at the second part of this lesson, and that's the midpoint formula. To find the midpoint between 2 points, you use the following formula. And this formula is really quite simple. If you want to find the midpoint between 2 points, you simply take your 2 points, you add the x's, and divide by 2. That will give you the x value of your midpoint. To find the y value of your midpoint, you add your 2 y values and divide by 2. So, x's added together, divided by 2, y's added together, divided by 2, and that will give you your midpoint. Let's go ahead and look at an example of midpoint. Here we have the ordered pairs -1, -2, and 7, 4. They're going to ask us to find the midpoint. So we take our x values, -1 and 7, and add them together. When we add them together we get 6, we divide that by 2, and we get 3. So the x value of our midpoint is 3. Then for the y value, we take our 2 y values, we add them together, we divide by 2, and we get 1. So the midpoint of -1, -2, and 7, 4 is the ordered pair 3, 1. Alright students, that wraps up our lesson for tonight, the midpoint and distance formulas. Please go back and make sure you have the formulas written down. They're very important. Okay, make sure you have the distance formula written down, make sure you have the midpoint formula written down, and make sure you come to class tomorrow ready to put these 2 formulas into action. Have a good night, Titans. Thanks for listening.
Made with Doodlecast Pro.